We talked a little bit back in the first week about integers. I want to review those again just because people tend to struggle with them, and go over some other things with them. Remember, integers are just our whole numbers, only they can now be negative as well as positive. And remember, we represented any value, positive or negative, on our number line with a vector. So any of our addition problems became vector problems. Something like 9 plus negative 5. Well, you had 9, negative 5, brought you back to 4. And rather than drawing out a number line every time, we could do it without. We could just, I use the picture always just to keep my mind straight. So if I have something like negative 28 plus 47, well, I'm thinking of it this way. There's 0, there's negative 28. Positive 47 goes the other way and it's longer, so it takes us into the positive side of things. We know our answer has to be positive. And since the vectors or the arrows go in opposite directions, we know it's the difference between 47 and 28. So 47 minus 28 will give us 19. So it's a positive 19 would be our answer. Subtraction is where it really got to be tricky. If we had a negative 12 minus 9, what do we get? Well, what did we change that to make it easier? Yep, there you go. So we change it to a negative 12. Remember, subtraction, we change it to plus the opposite. So minus a positive becomes plus a negative 9. And yeah, now we have negative 12 and negative 9, which is a negative 21. Or if we have 7 minus a negative 18, that was changed to become 7 plus a positive 18. So 7 and 18, of course, that's just going to be 25. We didn't really need to draw out the vectors for that one. Multiplication and division were actually quite a bit easier. Then we have negative 8 times 11. First of all, is the answer going to be positive or negative? It'll be negative. Anytime when we're multiplying or dividing, if there's one positive and one negative, the answer will be negative. If they're both the same, then it's going to be positive. So here we have a negative times a positive, so the answer is negative. And 8 times 11 is 88. Very good. We might have 13 times a negative 4. First of all, positive or negative? Negative. 13 times 4 is 52, so negative 52. Negative 9 times negative 8, the answer will be positive or negative? Positive. A negative times a negative will make it a positive. 9 times 8? 72. Very good. (42) divided by negative 6? Negative 7. Good. Well, you know it's a positive divided by negative, so one of each again means the answer is negative.
So it's just like multiplication.
It's like multiplication, yes. And 42 divided by 6 is 7. So the same here. A negative divided by a positive, so the answer will be negative. And 36 divided by 9, or 36 divided by 4 is 9. Our negative 48 divided by negative 16 is positive 3. Not so bad. With these integers, then, there is a symbol that we need to learn. It looks like this. I exaggerated it a little bit there. Those bars around a number are what we call absolute value. What it means, two ways to look at it. The technical way of looking at it is the length of the vector. So that arrow we drew on the number line, how long is it? Now length, of course, is always positive. Or the second way you can think about it is distance from 0. Both of them will give you the same result. How far is 8 from 0 on a number line? How many spaces? 8 spaces. Or its vector would be how many units long? 8 units long. The absolute value of 8 is 8. Likewise, the absolute value of 17 is... How long is the vector for 17? 17. Or it's 17 this way. Because that's how long it is. It's the length. Length is always positive. Now, what about the absolute value of a negative 12? Well, how long is the vector for negative 12? 12 units long. Absolute value is asking for a length or a distance, and a length is always positive.
Okay.
Now, that doesn't mean that whenever you see an absolute value, your answer will be positive. That's not necessarily so.
I was thinking when they, that they wanted, like for the 17, I thought they wanted a negative 17 because it's the opposite.
Oh, no, they're just looking for a length.
All right.
It doesn't mean the opposite, it just means the distance from 0, or the magnitude. It's like 8 minus 13 now. We talked about the order of operations. These absolute value symbols are an enclosing symbol. They're enclosing the 8 minus 13. So we have to do that first. What is 8 minus 13? Negative 5. Now we can do once we get it down to a single number inside there, then we can do the absolute value. And the absolute value of negative 5 is 5. But we can have problems like this. Again, each of these is an enclosing symbol. Is there anything to do inside this absolute value sign? No. So we can get rid of it, but when we get rid of it, we have to do the absolute value. What's the absolute value of negative 7? 7. Good. Minus, what's the absolute value of negative 13? 13. Now we have 7 minus 13, which is a negative 6. You think of that as 7 plus a negative 13. So you go positive 7, and then back 13 gives you back into the negatives. So you can see that there's a problem with absolute values in it, but the answer wasn't necessarily positive. So the absolute values themselves make what's inside of them positive, but it doesn't make the answer always positive. Here's another one that common mistakes. Does the absolute value make this a positive 20? No. We have to do everything inside it first. The absolute value only acts on this problem once when we get rid of the symbols. So we have to do 14 plus negative 20 first, which is negative 6. Just like in parentheses or any other enclosing symbols, you need to get what's inside of it down to a single number. Now that it's down to a single number, now that it's negative 6, now we can get rid of the absolute value symbols. This is when we actually do the absolute value operation. So to get rid of those symbols, we have to find the absolute value of negative 6, which is 6. Ooh, excuse me. I think I do, yeah. Let's look at something like this. Again, this is just order of operations. This is an enclosing symbol, so we can do what's inside there first. What's going to happen first? Yep, so 9 plus 7 is 16, and then minus 2 is 14. Now we're done with everything in there. It's down to a single number. We can get rid of the symbol. What's the absolute value of 14? 14. So the minus is still there. Then over here, another enclosing symbol with the opposite value signs. Inside there, we're going to do 3 squared, which is 9, plus 4, 13. Opposite value of 13, 13. So we got 14 minus 13 makes 1. What do you think? Okay. We've already seen some problems like this. What's that mean? 8 to the third power. How do we calculate it? 8 times 8 times 8. Yep. Now on your calculators, you do have a power button. We looked at that a week or so ago, right? Depending on your calculator, it'll either be a caret key or like an X to the Y key or Y to the X key. Some of the Casios have like something like this, blanks, grayed out squares there or something. So to punch that in your calculator, you use 8, then that key, and then 3. For those of you that have your calculator with, I'll have you try me with this one. 2 to the power of 11 should get 2048.
So you would hit, like, because I have that little, the caret?
Yep. So you do 2, then caret, then 11.
Okay.
It's like if you were to do 5 to the power of 4, it'd be 5, caret 4, should give you 625. Everybody get to work? Cool. So what happens if we have negative 5 to the power of 4? If you have your calculators, this is an important one to give a shot. Because your calculator is most likely going to tell you an answer that's not right. What's it trying to tell you? It's trying to tell you negative 625. That's not the right answer. Down on your keypad, you got your enter or equal sign here. There should be a negative in parentheses there. The negative 5 to the 4th power is 4 negative 5s multiplied together. What's negative 5 times negative 5? Positive 25. Times another negative 5 would be a negative 125. Well, times another negative 5, negative times negative should be a positive 625. So why is your calculator trying to say that it's negative? Well, yeah, you'll see I put parentheses here. If you don't do that when you enter it in the calculator, what your calculator sees, if you enter negative 5 to the 4th power like this, what many of your calculators see, order of operations would say you do 5 to the 4th power first, and then you apply the negative to it. So when you enter that in your calculator, you do have to do parentheses, negative 5, close parentheses, and then to the power of 4.
So depending on how many 5s you had, you could either have a negative or a positive number.
Yeah, because negative 5 to the 5th power will be a negative 3,125. Because now that's just taking the 625 times another negative 5, and a positive times a negative will be a negative. Do you see a pattern ending up there with the powers? Yeah, what is it? Well, if it's an even power,
then it's a positive.
It's positive. Because there's pairs of negatives that cancel out to become positive. If it's an odd power, it's going to be negative. So when we look at something like a negative 3 to the power of 5, we know right away that that answer better be negative because it's an odd power. And of course, that's going to be a negative 243. Or if you have a negative 7 to the power of 4, we know right away that's going to be positive. And negative 7 to the power of 4 is going to be 2,401. Because of that, this symbol again, square roots. So the square root of 25. What that's asking is what number squared equals 25? And of course that would be 5, right? How about the square root of negative 16? What number squared equals 16? Or negative, yeah, 4.
Negative 4 then?
Well, what would negative 4 squared would be?
Oh,
A positive 16.
Right, so it'd be,
There's no number that you can square to get a negative number. If you tried to punch this in your calculator, square root of a negative 16, it's going to give you an error of some sort. You can't square a negative number because there's no number that when you square it will be negative. When you square something, since squaring is an even power, the result will always be positive. So you can't ever square root a negative number.
Well, 2 odds make positive, or 2 negatives make positive, so if you got a square of 16, that's 2 negatives, so it automatically be positive.
Yeah, and that's what when you do the square root of 16, most of us say that that's just 4, but it could also be a negative 4, because negative 4 squared also equals 16. Now, there's also other roots like third roots. If I ask for the third root of 27, that's saying what number to the power of 3 is 27. So that would be just 3, because 3 to the third power is 27. Well, how about the third root of a negative 8? What number to the third power is 8? Well, it's 2 times 2 times 2, right? How about a negative 8, though? Is negative 2 going to work for that? Yeah, negative 2 times negative 2 is a positive 4, times another negative 2 is a negative 8.
I thought you said there's never going to be a negative answer.
Only on an even power. This is a square root, which means technically it's a 2 there. We don't write it.
Okay.
But this is a third root on a power of, bless you, on a power of 3, we can have a negative answer.
Okay.
So it's okay to do the third root of a negative number. We'll cover that more later. We're not going to actually worry about calculating these for now. All we're worried about right now. No, this won't be on the test. All we're worried about for right now is knowing which ones are possible and which ones aren't. Like if I had a fourth root, that's asking what number to the fourth power equals whatever. Let's say the fourth root of 81. That's asking what number to the fourth power is 81. That would be 3, because 3 to the fourth power is 81. But what if I wanted to know the fourth root of a negative 81? Well, again, your calculator would give you an error, because that's an even power. 4 is an even power. It'll only give us positive results. We cannot take a fourth root of a negative. Okay, now, with that said, if you were to go far enough in math, what I just told you is technically not true. Let's go back to the square root of a negative 1. There is nothing, as far as we know about real math, there are no two numbers you can multiply together to get a negative 1. Or no number you can multiply by itself to get a negative 1. Negative 1 times negative 1 is a positive 1. There's no number squared that will give you a negative 1. So you can't take the square root. What? 0.5 times 0.5 is 0.25. 1 times 1 is 1. I mean, the square root of 1 is 1. But the square root of negative 1 can't be done because there's no number that you can square to get a negative. So, at some point, years ago, they got bored. I'm guessing this happened before there was television. And they decided, yeah, probably. Well, they just decided, you know what? What if we could take the square root of negative 1? And what if we just called it I? They called it I for an imaginary number. They imagined this number and decided to use it. Literally. But you don't have to write this down. You're never going to test it on this. I'm just showing you this because I don't want to lie to you. I don't want to tell you it's impossible to take the square root of negative 1 and then later in life you find out, oh, they do it. Well, what they did is then they built a whole system of algebra called imaginary and complex numbers, a whole number system, where based on the fact that if we define the square root of negative 1 to be I, we're not going to use that in here. It's just, I don't want to tell you you can't take the square root of negative and then later realize, oh, there is a way to do it. There is a way to take the square root of negative, but it's in imaginary numbers. In real numbers, which is what our calculator works with and what most of life works with, in real numbers, there is no way to take the square root of a negative. The only practical application for imaginary numbers that I personally have ever used is in electronics. In electronics, you end up with complex and imaginary numbers with your phase shifts and stuff and AC circuits and things like that. Most of you will never have to worry about imaginary numbers. Unless you decide to go on and be a math teacher or something like that. So anyway, I wanted to show that to you because I'm not going to give you just part of the story. Well, we've talked about then problems like this.
You realize it is only Monday.
Uh-huh.
It's just hard for a Monday.
You run into problems like this. You got to wake up sometime for the week, right?
I guess.
I gave you guys a long weekend. You should be all ready to go.
To do the problem.
So yes, we have the closing symbols, so inside the parentheses. No other enclosing symbols inside the parentheses, so we go to exponents, which will be 2 to the third is the first one, which is 8.
What?
2 times 2 times 2.
Okay.
You did 2 times 3, not 2 to the third.
Yeah.
What would be next? 5 squared, which is 25. Now notice, that's not in parentheses, so the negative is still there. The 5 is squared, and it's being subtracted from something. Any more exponents? No. So next would be multiplication and division. Now I'm going to cheat a little bit as I do this. Then go left, right. 2 times 5 is 10. Plus 7 times 8 is 56. There's a minus. 25 plus 2 minus 6 times 8 is 48. And I still have to come back and hit the divide by 2. $48 divided by 2 is 24. What goes in front of the 24? Still being subtracted, so it's minus 24. Now it's adding and subtracting inside the parentheses. 7 minus 10, negative 3. Negative 3 plus 56 is 53. 53 minus 25 is 28. 28 plus 2 30. Minus 24 is 6. And what?
Is it 3 times 6?
Yeah, we take out the parentheses and put it in time. So 3 times 6 would be 18. So 8 plus 18 is 26. Hold on. So even with the negatives in there, it's still order of operations. You just got to keep track of the negatives. The hard part is figuring out what's a negative and what's a minus, because they can kind of be interchanged. But you have to be careful. Like here, that was 5 squared, not a negative 5 squared. It'd have to be parentheses around it if they wanted to make it a negative 5 squared. So even after you square it, you get 25, but it's still being subtracted. So things like that to be careful of.
And that would be the only way that would be a negative 5 squared is if it were
If it was in parentheses.
Otherwise,
Otherwise, it's minus the 5 squared.
okay.
Or we might have something like that. or something like this. Now remember, the key to this is this thing across here, which is it's division. It's the fraction bar. And it's telling us to divide, but again, it's also an enclosing symbol. You have to do everything that's on top first. So on top here, what has to be done first? The power. And it is a negative 3 squared, so it is 9. That's 5 times 9. That's what has to be done next as well. So it's 45. And then 3 plus 45 is 48. This is 48 on top. Now we need to find on bottom. What do we have to do first on bottom here? Enclosing symbols. Is this one this parentheses? Is that an enclosing symbol? No, it's not. It's just separating out the negative 2. This one, however, is. We have to do inside that set of parentheses first. What do we do first? 5 squared, which is 25. And then 25 minus 19 is 6. Now I've reduced everything there to a single number, so I don't need the parentheses anymore. I don't need to add any or to put in any operations there because there was a minus in front of it. Now I have the 6 times the negative 2, which is negative 12 minus 6, negative 18. Negative 18. There you go, 48 divided by negative 18, which isn't going to come out, but we know it's going to be a negative, then whatever. Yeah, that'd be 12, negative 12 plus a negative 6, which becomes negative 18. And then, of course, 48 divided by negative 18 is going to be a negative, but it's not going to come out evenly. It'll be a negative 2 2/3 or 2.667. So the final step with these is to go that next step of, okay, what if we don't have a certain number? What if we don't want to use the same number all the time? And we might have a formula like this. Where we have letters in there. Those letters are variables. They're just a generic value waiting for us to give it a number. And let's say the situation tells us that x is going to be 3, b is going to be a negative 6, and d will be 3. And of course the command we would be given here is evaluate. Whenever you see evaluate, that means you're going to be taking numbers and using them to replace variables, and you're going to be getting a single number answer. Let me repeat that. Evaluate means you are going to be getting a single number for your answer. No variables. The other side of that is if you'd be told to simplify. If you're told to simplify, you're most likely going to have an algebraic expression for your answer. Like if you're told to simplify and then given 8x times 5x minus 2, you are not going to get a single number answer here. You've got 8x times 5x is 40x squared, and 8x times negative 2 is negative 16x. That's as far as you can go. You simplified it, but you can't reduce it to a single answer. Evaluate means you are going to reduce it to a single number answer. So anyway, evaluating here means we're going to replace all these variables with the values we give them over here. So 9 minus x becomes 9 minus 3. 12 minus d is going to become a negative 6. I'm going to put it in parentheses there. Times d is 3 plus 1. Now, I stress, do not, whatever you do, do not. I will catch at least half of you on the test doing this. Don't do 9 minus 3 equals 6. Why not? Yeah. The 3 multiplies that parentheses. The 3 has subtraction and multiplication. Which one has to happen first? Multiplication. So this 3 has to multiply on this side before it can be subtracted on the other. Which means you have to have everything in those parentheses done so that we can multiply the 3. So in the parentheses, are there any other enclosing symbols? No. Powers or roots? No. Multiplication or division? Yes, so we got to be careful here. This is kind of tricky. This is negative 6 times 3 is negative 18, but there is still a minus here. We didn't use that minus at all yet. We used the negative 6 and the 3 to get the negative 18. Now inside the parentheses, we have the 12 minus a negative 18, which is plus a positive 18, the 30. $30 plus 1, 31. Now what? 3 times 31 is 93. So it's 9 minus 93, negative 84. Positive 9, negative 93, get a negative 84. There's a new quiz due Tuesday at 11:59 p.m. There will be a new homework due Wednesday. And of course, Unit 1 test will be in class on Wednesday.